Welcome to Farmhouse Hobby Hunters. I'm Nick. I would like to start by saying that septic systems is not a hobby or a passion of mine. I am a homeowner. I do not repair, replace, or maintain septic systems for a living. That being said, I did do a lot of research on how septic systems are designed and built. I'm going to try to simplify the processes that I went through in order to design and build my own septic system. I'm also going to be including a link to a book that I found after repairing my system that I think would be very useful to somebody else that's going through a similar situation as I am. In 2019, my wife and I purchased our first home and immediately stepped into a mild nightmare. There were so many things wrong with this home, and we weren't really sure how it passed inspection or the appraisal. One of the issues with our home was our septic system. I believe part of the issue is that the location that we live in has an extremely high water table. The other thing that I believe was an issue is it was just improperly installed. As I recap this, it may seem like I reacted quickly to the situation, but honestly I did not. We were in the middle of renovating our kitchen at the time, and I didn't really have time to deal with my septic system, so I kind of put it on the back burner. So again, we closed on our house in April of 2019. My property was flooded for the majority of the next couple months because of winter weather. After things started drying up, I noticed there was water bubbling up in the backyard. I thought there was a broken pipe, so I dug up the yard and found that the septic system was overflowing into the yard. We might or might not have nosy neighbors. So the next thing that happened was that we got a letter from the city stating that they were aware of our septic system issues and they needed us to call them and to fix the situation. Because of the nature of the repair, it was classified as a major repair and the permit fee was $650. And then each year, if the work has not been completed, the renewal fee is $250. We needed to determine the cause of the septic system failure. Because the high water table was already suspected, I was then tasked with digging a test hole. That test hole was supposed to be 3 feet wide by 5 feet long by 5 feet deep. But I ran into water around 2 feet deep. That determined that we needed an above ground sand filtration septic system. From there, it was up to me to come up with a drawing of the rough location of where I wanted the sandbox to be located, along with a description of the processes and materials that will be used to complete the repair. It's important to remember that this plan can change mildly here and there. I got really caught up on that and it took me forever to even submit anything because I was worried that it wasn't going to be exactly where I wanted it to be in the end. One thing that did change from my original plan was I had the dosing tank located over the fence in the backyard. The final result was that the dosing tank was actually located in the field on the other side of the fence outside of the backyard, which was way more convenient when having the dosing tank dropped into the ground. My specific system required me to have 1,500 gallons of holding capacity for wastewater. I already had a 1,000 gallon septic tank, so we just added a 500 gallon dosing tank, and then the wastewater would be pumped from the dosing tank to the sand filter. I purchased the pump, the float tree, the riser, the cap, and the control box from a company called RC Worst, W-O-R-S-T. That company was extremely helpful when it came to knowing exactly what I needed for my system, and they even helped me out with some drawings that came from other people's systems. The actual footprint of the sand filter box needed to be 360 square feet. The sandbox I designed is 18 foot by 20 foot. Another thing to take into account while designing your system is the elevation changes of your property. My property is very flat, but I'm dealing with high water tables. That became an issue when I was trying to dig a hole that was deep enough for the dosing tank in order to have the proper elevation change from the septic tank to the dosing tank. There are also inspections that you have to have done periodically throughout the process. I will go more into depth with that later. For now, let's just get into the repair footage. Here's the frame being laid out on the ground in the location that I chose. The ground underneath was scraped clean of any grass or weeds that originally grew there. Once the walls of the frame were stood up and supported by 2x4 framing, we had inspectors come. Then we added 6 inches of round pea gravel and another inspection. After the pea gravel, we added 24 inches of DEQ approved sand, which means the sand has been cleaned and is very expensive. The next layer is 3 more inches of round pea gravel, then the PVC, and the last 3 inches of round pea gravel. After adding each of these layers, there was an inspection due. After constructing the grid with the PVC, the next step was to drill holes that are 1/8 inch diameter through the top of this PVC pipe. So I went through and I measured so that I could get everything spaced out evenly, 72 holes throughout the whole system. There are 8 PVC pipes going long ways, 9 holes per line. And then the next thing is to add what they were calling an orifice cover or an orifice shield. An orifice shield, there are different types. This one is one that we made. So this pipe is all 3/4 inch coming from the dosing tank. This PVC pipe is 1 inch, and I cut it into 4-inch increments. We heated up each end, with a heat gun, and then pushed in the edge. And what that does is makes it so that there's an opening to allow water to spill out. And then we took and I set up a stopper on the miter saw and cut these for extra water relief so that there's somewhere for the water to spill out and doesn't just push this off. And so these will all snap right in place over the top of these orifice holes. Just like that. So 72 of those will be installed. The next step is going to be adding 3 more inches of gravel all the way across, and then after that we'll be adding garden fabric to prevent weeds from going down through and to prevent the dirt that's going to be added on after that from seeping into the gravel and completely clogging up the entire system. Oh, and another thing to point out, the purpose of this is to allow water to spill out, but also so that gravel can't completely fill all of these holes. We don't want anything blocking those orifice holes from allowing the water to splurt out. Once the PVC grid had been constructed and all of the orifice holes had been drilled, it was time to test the system to make sure the pump would push the water out of the holes. Also, an inspector had to come at this point. Then it was time to add the orifice hole covers. Here's the control box that has been wired up to turn on the pump when the waste levels have risen too high. There is a separate permit and inspection because you have to tap into your home's existing electrical. This is the original septic tank to the system. The septic from the house runs into it from the backside. The pipe you see here will be leading to the dosing tank. Here is the riser that houses all of the electrical connectors along with the float tree and pump. The riser, cover, effluent pump, control box, and all associated hardware was delivered for roughly $3,300. Here's a better view of the 500-gallon dosing tank that I purchased. It was delivered and placed in the hole for $1,150. From the riser, the wastewater is pumped through 3/4 inch Schedule 40 PVC. There is also a green tracing wire that runs along all PVC and electrical conduit. After the last 3 inches of round pea gravel was added, we trimmed down the edges of OSB and added garden fabric as a barrier between the pea gravel and the dirt. So the last part of the septic system is these black covers. They go over these ports where I have to have a service contract with a local septic company to come out and inspect it yearly. And so they will have access here to blow out the system if it ever gets clogged or anything. And so these will go over the top right there so that they can get into them. And 14 inches of soil goes over the top of this, and then we need to seed it so that it has grass or something growing on top of it so that the dirt doesn't just get blown away by the wind and the elements. So yeah, if you guys have any questions about the system, let me know in the comments, and good luck, because this is a huge project.